there, Narek is here. Today I'm gonna talk about the square roots of a real number. So let's start. What do we understand by square roots? First, we have to take into consideration the power of real numbers, and especially in this case, the degree, which is 2, the power, which is 2. So let's say we have a certain variable x to the power of 2, and it gives me a result, and I'm going to call this result a. The answer is a. If a is positive, I will have 2 real roots. If a is equal to 0, I will have 1 real root. And if a is negative, I will have no real roots. What do I understand by this part? Let's say we have x squared is equal to 9. Which number times the number itself, it gives me 9? Very simple. We can remind ourselves that plus 3 to the power of 2 was actually 9, or minus 3 to the power of 2 was again 9. So whenever I'm doing the reverse pathway, I'm trying to find the square root of 9. So x squared is equal to 9. What about x is the square root of 9, or the negative square root of 9. So this is how you write the square root. Square root of 9, it will be x is equal to 3, or x is equal to minus 3. And exactly, you had plus 3 to the power of 2, 9, minus 3 to the power of 2, 9. Now, let's say it was x squared to the power x squared is equal to minus 9. In that case, you will have to say no real roots. And if x squared was equal to 0, you will have to say 1 real root, which is 0. Alright, so I'm going to take examples related to this part. Let's say we have x squared is equal to 7. As you can see, a is 7. From this you can deduce that x is equal to plus square root of 7, or x is equal to negative square root of 7. Now, of course, if you'd like, I can mention that these are 2 real roots, since a is positive. What about x squared is equal to 0? Now in this case, x is equal to 0, and you have 1 real root. What about x squared is equal to minus 5, let's say? A is negative in this case, so you have to say no real roots. There are no values which you are gonna multiply by itself or take it to the power of 2, and it's going to give you a negative answer. So it cannot be minus 5, just like in this case. So x squared is equal to minus 5. It's impossible to have this case, so no real roots. Alright, now what about the square root of a squared? You simply have to say it's plus a if a is positive or equal to 0, or square root of a squared could be equal to minus a if a is negative. Okay? Similarly, you have square root of a to the power of 2. It can be written as minus square root of a to the power of 2, which is a. Whenever we're going to talk about the square root of a, it's very important to say that a should be positive or equal to 0, or else it will be meaningless. Square root of minus 5, let's say, I'm going to take a small example. Square root of minus 3 does not exist. Square root of 3, it exists. It's 1.7, etc. So you have a certain irrational value for the square root of a when a is positive or equal to 0. Now, what are the properties related to the square root of a real number? The first one, whenever you have a, b, and c, real numbers, but I'm going to consider them positive, the first property that you have is the square root of a times the square root of b. It can be written as the square root of a times b. Similarly, when you have square root of a times the square root of b times square root of c, it can be written as the square root of a times b times c. Let's take an example. So, square root of 3 times square root of 2 is equal to the square root of 3 times 2 is the square root of 6. Square root of 3 times square root of 2 times square root of 5. You can write it down as square root of 3 times 2 times 5 is the square root of 30. Alright? Now, let's take the second property. The second property. When we have the square root of a over square root of b, it can be written as the square root of a over b. And of course, we have to mention that b should be different than 0. We already said previously that a, b, and even c should be strictly positive. Let's take an example related to this case. The square root of 2 over the square root of 3, it can be written as the square root of 2 over 3. Similarly, when we have the square root of 6 over the square root of 3, it can be written as the square root of 6 over 3, so it's the square root of 2. Alright? So, the next one, I'm gonna give you some remarks related to operations with square roots. Whenever you have the square root of a plus the square root of b, it's not the same thing as the square root of a plus b. Example, square root of 6 to the power of 2 plus square root of 8 to the power of 2, it's 6 plus 8, which is 14. As for the square root of 6 squared plus 8 squared is the square root of 100, which is 10, and it's totally different than 14. Alright? So this is related to the square root. Similarly, we have again the second remark. Square root of a minus square root of b is different than the square root of a minus b. Let's say square root of 8 to the power of 2 minus square root of 6 to the power of 2 is equal to 8 minus 6, which is 2. As for the square root of 8 to the power of 2 minus 6 to the power of 2 is equal to the square root of 64 minus 36 is equal to the square root of 28. And the square root of 28 is actually 5.29, which is different than 2. Alright? So this was the part related to the square root of a real number. why don't you subscribe to my channel, because I'm gonna upload new videos and you will be notified. I can also share with you my Instagram and Facebook account in case you want to contact me, or you can simply leave a comment below. I hope it was helpful, and see you next time.